Hi Year 9, so we're starting a new topic on ratios and rates. So you should have a new booklet which has a green cover on it, and we're going to start having a look at that. So the first thing we're having a look at is ratios. So when we're talking about fractions, ratios and rates, we're comparing quantities. So the example that you've got up here is that a lawnmower might require 1/6 of a litre of oil to make a petrol mix of 2 parts oil to 25 parts petrol, which is an oil to petrol ratio of 2 to 25 or 2, which we write as 2 to 25. But our 1/6, so we've got a fraction happening, we've got ratios happening. So ratios are used to compare quantities with the same units, and that's something that's very important. So if you've got a ratio, then it could be litres to litres, it could be kilograms to kilograms, or we could be talking about millilitres to millilitres or buckets to buckets. It doesn't matter, the units are the same. And when we're writing a ratio, if we were to write the ratio of A to B, then the format that it gets written in is A and then a semicolon and then B, and we read it as A to B. Ratios in simplest form use whole numbers that have no common factor. And one thing you also need to remember is that the order of a ratio is important. Okay, so if it is the ratio of apples to oranges, then the quantities that we have in our ratio has to have the apples first. Okay, and then the unitary method that we've got here involves finding the value of one part of a total. Okay, and then once the value of one part is found, then the value of several parts can easily be determined. So let's have a look at some examples over the page. Okay, so for example 22, we're simplifying ratios using HCFs. And HCF, you might remember from previous years, is the highest common factor. So it's the highest factor that is shared by two or more numbers. So our highest common factor means that we only have to do it once. So to simplify the ratio, 38 to 24. So you think to yourself, what number goes into both 38 and 24? If you can find the highest number that goes into both the highest common factor, it's a much quicker process and we only have to do it once. Otherwise, you might have to repeat the process. But repeating the process is also sometimes not a bad thing. It doesn't, just is longer, but we can still do it. So you might recognise that both numbers are even, and so the highest, a common factor of both of them would be 2. So we're going to take our 38 and divide it by 2, and we're going to take our 24 and we're going to divide it by 2. So we're dividing both parts of the ratio by a common factor. So 38 to 24, we're going to divide 38 by 2, which will give us 19. And we're going to divide 24 by 2. So we've got 19 to 12. And 19 is a prime number, so there's not going to be any more common factors. So 2 was the highest common factor in that case. If you looked at those two numbers and you had a common factor still, then you would simplify further. So for example, if I just do one more example over here, let's say I had the ratio of 36 to 24, and I knew that they had a common factor of 2 because they're both even. If I divide those two by 2, 36 divided by 2 is 18, 24 divided by 2 is 12. They're both still even, they both still have a common factor. And maybe now I recognise that they've got a common factor of 6, and I could divide them both by 6, and then I would have 3 to 2. Okay, so you're looking for the highest common factor to make it a quicker process. For example 23, we're simplifying ratios involving fractions and decimals. So when we write a ratio, we want to write it using whole numbers. Okay, so we want to not have decimals and not have fractions involved. So what you think to yourself is, what number can I multiply by so I have a whole number? If you've got decimals, it's going to be a power of 10, so 10, 100, 1,000. And for a fraction, it will be a common multiple of the denominators. All parts of the ratio need to be multiplied by the same amount. So with question A here, when you multiply by a power of 10, it moves the decimal point. So with the first ratio, 0.2, we need to get the decimal to move one place. But with the second ratio, we actually need it to move 2 places. So we need to times by 10 and times by 10 again, which means we're timesing by 100 to move the decimal place 2 places. So for A, we've got 0.2 to 0.14. I'm going to multiply both parts of the ratio by 100. Okay, so 0.2 times 100 is going to give me 20. And then 0.14 times 100, it moves the decimal place 2 places, and so we end up with 14. Then we can simplify like we did above. So we look for our common factor, and our highest common factor is 2, so I'm going to divide by 2 on both sides of the fraction. So I get 10 to 7. Okay, with question B, we've got 2.5 to 1 1/3. Okay, now we kind of need to be able to get rid of those fractions. So what I'm going to do first of all is I'm going to write them as improper fractions. So I'm going to take the 2 wholes times by the 2 and then add it to the 1 up here. So we end up with 2 times 2 is 4, plus 1 is 5 over 2. So 2.5 is the same as having 5 halves. And then 1 1/3, so I do the 1 times the 3, which gives me 3, plus 1 more is 4 over 3. Now I need to find a common multiple for 2 and 3. So a common multiple of the two of them would be to put them over a fraction of 6. So my left-hand side, I've times by 3, so I need to do the same thing to the numerator. So I times the denominator by 3 to get 6, so I'm going to times the numerator by 3 to make an equivalent fraction of 15 over 6. On the right-hand side, I had to times by 2 to get the denominator of 6, so I'm going to times the numerator by 2 as well to keep it as an equivalent fraction. So I've got 15 over 6 is equal to, 15 over 6 to 8 over 6. And then to get rid of our denominator, okay, the bottom of our fraction, we're going to times both sides by 6. So our fraction is 15 to 8. Our ratio is 15 to 8. Okay, the last example we're going to run through today is simplifying ratios involving units. So remember that a ratio is a comparison of two numbers that are in the same units. So that means that if we've got, in this question, we've got metres and kilometres, we need to change them so that they're both in the same unit and then simplify our ratio. So I've got 560 metres to 2 kilometres. So I could convert the metres to kilometres, but then I'd end up with a decimal. So what's actually going to be easier is going to be to rewrite it as 560 metres to 2,000 metres. And now that they both have the same units, I can write it as a ratio and simplify. So we've got 560 to 2,000, and we've got to look for the highest common factor. I don't know my factors of 560 and 2,000 off the top of my head, but they both end in a 0, so I'm going to start by dividing by 10 so that I get 56 to 200. Then I can see that they're both divisible by, you might recognise that they're divisible by 2, so you could divide by 2, or you might even recognise that they're divisible by 4. And so we can divide both parts of the ratio by 4. And we get 14 to 50. It might have even been divisible. Now it's still divisible by another 2. So I'm going to divide by another 2. And I'll get 7 to 25. 7's a prime number, so I'm not going to have any common factors between 7 and 25. And 25 is not a multiple of 7, so I can't divide by 7, so that's going to be my solution. All right, so what I'm going to get you to do once you've got all those examples down is you're then going to be finishing exercise 1G. On page 33 of the textbook, you need to do all of question 2, the first column of question 5, the first column of 6, the first column of 7, and the first column of 8. Don't forget you need to show your working, not just put an answer on the page. So I want to see the working happening on your page.